In this video we'll have a quick look at the controls. The controls were originally approached in two very different ways on both sides of the ocean. The Europeans were focusing extremely on stability, making sure the aircraft would fly in a straight line, and this hampered them in achieving agility. The Wright brothers made their aircraft slightly unstable, and this allowed them to be much more agile and maneuver much more. Their elevators in the front were much larger, and they were able to make tight turns and drew a lot of attention with their maneuvers. This was actually one of the things they were better in than their competitors. So how did they make those turns? Well, the technique they used for this was what is called wing warping. Instead of having rotating surfaces on the wing, they pulled some of the wires and changed the shape of the wing asymmetrically. So one side became more curved, more cambered, while the other one became flatter or even a negative camber. And this resulted in an asymmetrical distribution of the lift force over the wing, which made them bank or turn. This bank angle caused then, if they were at this certain bank angle, caused the lift factor to point inwards, and they also had to pull a bit to generate more lift to still maintain the weight, compensate the weight, and the resulting extra force is the side force which pulled them through the actual turn and allowed them to maneuver. Well, after the wing warping, which was still used for quite some time, actually, in fact, the Fokker Spin, the first Dutch aircraft made by Fokker, though based on a kit from originally Germany, I think. The first Dutch aircraft, the Fokker Spin, also still used wing warping, while at the same time in Europe there were already experiments with ailerons, so surfaces connected to, as you can see it here, little surfaces which could turn, connected to the wing. And this was basically a precursor of the aileron as we know it today. And this was in 1909, so this was the same, you can see it here full screen. It was the same time that Fokker was still using his wing warping on the Spin. If we look at today's flight controls, they are basically the same as this ailerons by Emile Aubren on his Antoinette. There are in fact, next to the control surface, there is another control. There are in fact 4 controls, 4 ways in which the pilot can control the direction that he flies. The first is the thrust, with which you control the forward acceleration and hence the speed, also the forward speed. Next control are the ailerons, with which you control the bank angle. You can roll the aircraft with it. Then we have the elevator to control the nose up, nose down, the pitch. And the rudder to control the yawing movement, the heading, where the aircraft is heading. So there are 4 controls. But in 3-dimensional space, there are 3 translation axes and also 3 rotation axes. So in total, there are 6 degrees of freedom. And there are only 4 controls. And it was Mr. Stinton who said, well, it's actually not immediately clear how with 4 controls one manages to influence the 6 degrees of freedom of an aircraft. So how is this possible? You're only able to control 4 degrees, with thrust being a translation and the other surfaces all controlling a rotation, and still we're able to control 6 degrees of freedom. This is a nice question to think of yourself. If you want to, then you can press pause now, and then afterwards I will tell the answer. So what is the answer? Well, let me first explain by an analogy, a much simpler analogy. Imagine you would have a car for which the speed was fixed and you could only turn the wheel. with this car, you would still be able to reach all positions, so all combinations of X and Y. So with this 1 degree of freedom, the steering wheel, you can apparently control 2 degrees of freedom, the X and Y, and even the third one, the angle in which you're heading, the heading of your car. So you can control even 3 degrees of freedom with only one control on this flat surface. And this is because the effect of time. When you have forward speed, your position is basically the result of an integration of your speed over time. And because you can influence how this speed affects the different degrees of freedom, you can reach more degrees of freedom than the ones that you control. So with this aircraft, the short answer is basically due to its forward speed, which results in integration over time. But okay, let's, after this short sidetrack, let's look at how the control system is actually mechanized, how it was made originally and how it's made today. Well, we already saw at the Wright brothers, it's a simple system of cables, even when the wings were still warped. Same was true with the control surfaces. It's a system of cables. And here we see a schematic way, but close to the original design of a classic flight control system. Classics means cables are being pulled which control the surfaces. The first control, the elevator, is by pulling the control wheel or the stick. It results in a force on the cables, resulting in an upward motion of the elevator, which pushes the tail down and causes your nose to go up. So the elevator control is by pulling or pushing for nose down the control wheel. Next control is the aileron. By rotating your control wheel or moving the stick sideways, you differentially pull and release 2 cables, which will result in an upward and downward movement of the 2 aileron surfaces, causing the aircraft to roll left or right. The rudder is controlled by the pedals with your feet, and in a bit of an odd way, that if you push on the right side, the rudder extends to the right side, and this causes the nose to also go to the right side. For some people this is logical. If you push right, you go right. But ones that have actually made a little car themselves once as boys would expect it the other way around, because with a stick the aircraft moves as if you move the stick, while here you move the pedals to the left and the aircraft goes to the right. But if you look at the way the cables are arranged, this is a very logical reaction, and for some people it's also intuitive. So apparently the population is mixed in that sense, and it's of course would be impossible to reverse it right now. So these are the ways in which you control the surfaces. But nowadays you often have a system which is called fly-by-wire. And fly-by-wire means that the stick or the control wheel is no longer attached to the surfaces by cables, but there's actually a computer in between, and this has a lot of advantages. For military aircraft, you could make your aircraft more agile by having it basically unstable and let the computer stabilize it. For airliners, the main reason to introduce this is not to design unstable aircraft, but simply to save weight. These electronic wires are lighter than the heavy cables which you need for large airliners. And that's why modern airliners are also fly-by-wire, just like modern fighters. So far for the controls. In the next lecture, we'll have a look at some definitions for angles and axes.